So another kind of transformation that is known as Laplace transformation I am going to discuss. So this is a very important transformation, Laplace transformation, and there the limit in Fourier transformation was from minus infinity to plus infinity, and in Laplace transformation the limit will be from 0 to infinity. Okay, so the problems involving spherical polar coordinates and problems involving cylindrical coordinates, Laplace transformation will be used, because you can see that limit in this case will be 0 to infinity. And this is uh, basically a tool to solve partial differential equations. So Laplace transformation is a tool to solve partial differential equations. And what type of problems we can analyze here is electrical networks, springs, mixing problems, mixing problems, signal processing, signal processing, and other areas of engineering and physics. Okay, so this has got wide range of applications, uh, starting from electrical networks to springs, mixing problems, signal processing, and other areas of engineering and physics. What are its advantages? What are the advantages of using this? So problems are solved directly. What do you mean by this? That in normal case, how we solve the differential equations? First we get general solution, then we apply the initial conditions. So because initial conditions are used directly, आप देखोगे जब मैं solve करूंगा, are used directly. Initial conditions are used directly. Okay, non-homogeneous equations are solved directly. Like in previous case, we used to solve non-homogeneous equations by putting first right hand side 0. That means firstly we were calculating the complementary function and then coming on the uh, particular integral. But in this case that is not required. That will be also solved directly. So the main issue is if the right hand side is some discontinuous function, okay, right side is some discontinuous function, then also you can uh, handle it using Laplace transformation, like Heaviside function or Dirac delta function. So all these can be handled very easily in Laplace transformation, whereas it is not easy to handle them in our normal procedure. Okay, so impulse function, is impulse function. So all that can be handled very well in this Laplace method, and they were not easy to solve in normal your procedure. Okay, now this was just introduction. So now let me come to what is the definition, because if I am saying it is a transformation, it should have a definition. So what is that definition? Let me take that. So the definition, like in Fourier, I gave you a definition. Suppose you have a function ft. Okay, ft is a function, and we convert it to Laplace space, and that is known as fs. So conversion of this to this is Laplace transform, and conversion of this back to this is inverse Laplace transform. So conversion of the function to this function fs is Laplace transform, and conversion of this function back to ft is known as inverse Laplace transform. So what is the definition? The definition is given by f of s is equal to 0 to infinity. I told you the limits are 0 to infinity. F of t e to the power minus st and dt. So you can see, and s is a positive quantity. So you can see that limits will be put in t. So finally t will be gone. What will remain will be the function of s. So that's why these two are, they form the Laplace transformation pairs. ft का Laplace transformation will become fs, and fs का inverse Laplace transformation will become ft. And what I have to do in this case is we have to just work out on some very fundamental transformations, and we will be using those transformation to do complicated transformation. This is how this Laplace transformation is studied. So for example, I can start it from, and this is the definition. Even if you know this, अगर ये definition भी पता है, तो in many cases we can solve problems, because 0 to infinity वाली limits, the integrals involving 0 to infinity, we have little idea about it. We have already done many questions on it, so we will be able to do. So first thing is to remember the definition, everybody. Okay, so this is also integral transformation, so obviously linearity property this will also follow, huh? Linearity property, this will also follow linearity property, no problem, because integral is there, so integral will be applied and you will get the transformation. Okay, now let us see some basic transformations. So some basic transformations, please note down. Suppose this is ft and this is fs. Okay, so suppose ft is 1 e to the power at sine hyperbolic at. These are the functions. Cos hyperbolic at, sine at, cos at, and t to the power n, and ut t minus a. That means unit step function. Okay, so let us understand how the Laplace transformation of these are. So one is 1 upon s e to the power at is 1 upon s minus a. Please see this. This will be very, very symmetrical. When there is sine, it will be a upon s square minus a square. When it will be cos, it will be s upon s square minus a square. When it is sine, it is again a upon, now this is s square plus a square. When it is cos, it is s upon s square plus a square. इसका याद रखना बहुत जरूरी है. T to the power n, that is gamma n plus 1 over T to the power n is n factorial upon s to the power n factorial over s to the power n plus 1. That means we can also write it like gamma n plus 1. This can be written as gamma n plus 1 over s to the power n plus 1. So these are the basic transformations that we have to remember. So this is t to the power n, and then finally unit step function is e to the power this. ये इसका है. What is this unit step function? It is e to the power minus as upon s. E to the power minus as upon s. In this case, s is greater than a. In this case, s is greater than a. So wherever it is in the denominator, it is s greater than a. Note down this first of all. That is the first step of Laplace transformation. These 8 transformations we have to remember because we have to do it very, very quickly. So we have to remember all these. So there is a symmetry, if you can see, that when it is sine, a is in the numerator, and for hyperbolic x square minus a square, for normal sine cos s square plus a square. This is completely different. So ये आपको याद रखना पड़ेगा. This is unit step function. So we can calculate any one of them. Like I can show you the transformation of n. ये note कर लिया सबने? Now please see. If I take any one of them for the transformation, suppose I want Laplace of e to the power at is equal to question mark. So the same definition will be used, that fs will be equal to integral 0 to infinity e to the power at e to the power minus st and dt. This is the transformation. So this will be equal to 0 to infinity e to the power minus s minus at and dt. Now that's why s should be greater than a, otherwise we can't integrate, we can't put limits. So it will become minus 1 upon s minus a and e to the power minus s minus a t limits 0 to infinity. So it will become 1 upon s minus a 0 minus 1. So that's why 1 upon s minus a. So this is very, very important, because using this we can do this also. This is what? When a is 0, If you put a is equal to 0, it will become 1. So a 0 रख दो, 1 upon s आ जाएगा. This can also be written using exponential. 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 So all these are just exponentials. So इसमें से कोई भी randomly पूछो, मैं करके दिखाता हूँ कि exponential का use करके कैसे करना है.
स्टेप फंक्शन वाला कर दीजिए.
अरे उसका रुक जाओ यार, मैंने बोला इसमें से कोई, पहले ही सुना तो करो. I am asking that exponential you have done, you can do first, second, third, fourth, fifth, sixth, any one of them.
सर हो जाएंगे सारे. सर ये वाले हो जाएंगे.
So any function you can do using this. So like suppose you want sine hyperbolic Laplace. So it is very easy, because just you write e to the power 80 minus e to the power minus 80 by 2. यही तो है.
यस सर.
Yes, sir.
And what will be Laplace of this? Laplace of this will be 1 by 2. 1 by 2 is e to the power 80 is 1 upon s minus a, minus e to the power minus 80 will become 1 upon s plus a. आ रही बात समझ में?
Yes, sir.
यस सर.
So this will become half of s plus a minus s plus a over s square minus a square. This will cancel, and 2a, this will become 2a, so this will become a upon s square minus a square. Please see this. See this and tell me. So using this you can do any of the sine, cosine, and suppose I do, this is clear to everybody or not?
Clear, sir.
यस सर.
Clear enough? So suppose I do it for, and you have taken it down also?
Yes, sir.
So suppose I do it for sine 80 without hyperbolics. So sine of 80 Laplace, suppose I want, question mark, it will be half 1 by 2i e to the power I80 minus e to the power minus I80, question mark. इसका Laplace लिखना है. It will become 1 by 2 iota. For this it will become 1 upon s minus Ia, and minus, for this it will become 1 upon s plus Ia. Correct? When you solve this, it will become 1 by 2i s plus Ia minus s plus Ia over s square plus a square. This will be cancelled, and you will get 2 iota a, which will be cancelled from here. So you will get a by s
S
square
square
plus
A square.
a square. So if you are open to mathematics, you know the basic formulae, basic rules and calculations, you can go. No problem. This one is okay?
Yes, sir.
Yes, sir.
So now we have done up to this. We know up to this. Now t to the power n. So Fourier of t to the power n will be Laplace of Fourier बोल देता हूँ. Laplace of t to the power n will be given by 0 to infinity t to the power n e to the power minus st dt. Correct? Yes?
Yes, sir.
And what is the formula? Gamma n plus 1 upon s to the power n plus 1. This is the direct formula which we know for this integral, the gamma integral. Yes or no?
Yes.
So this formula we know directly. Two
Yes, sir.
formulas we use ना, एक में x square होता है, एक में without square होता है. So these formulas are very very important. So इसमें तो कुछ भी नहीं था t to the power n में ना, and this is written as n factorial over s to the power n plus 1. Correct? Now unit step function. This is clear?
Yes, sir.
जिन्होंने पूछा था अभी, आप समझ गए भाई?
Yes, sir.
अंशुल,
Yes.
अब ये तो डायरेक्ट फॉर्मूला है ना, दिस इज डायरेक्ट फॉर्मूला.
Yes, yes.
Next one is unit step function. So unit step function is like this. This is a ut minus a. After a the value will be 1. This is what is the meaning of unit step function. Correct? This is t and this is ut minus a. Now the Laplace will be equal to integral 0 to infinity ut minus a e to the power minus st and dt. So this will be 0 to a. 0 to a, the value is 0. And a to infinity, the value is 1. This one goes to 0. That one becomes e to the power minus st over minus s, a to infinity, which is minus 1 by s e to the power minus infinity minus e to the power minus as. So this becomes e to the power minus as upon s. And in this also you can see that s should be a positive number. Otherwise here this infinity minus infinity will not be there, because you know what is this? It is e to the power minus s infinity. So s has to be positive. Okay, so this is for your step function or unit step function. Is called unit step function. Unit step. Tell me if this much is clear to everybody. कुछ अलग से एफर्ट करने की जरूरत नहीं पड़ेगा, आप बस यहीं पे सीख सकते हो विद इन द क्लास दैट द अमाउंट दैट इज रिक्वायर्ड फॉर योर एग्जाम, बट इट इज अप टू यू. कई चैप्टर्स ऐसे हैं जो कई दिन लगा के भी नहीं कमांड हो पाता, बट दीज थिंग्स आर immediately you can just get command on it. So this much formula we should know if we want to calculate the Laplace of so many things. So like you should remember this much, that 1 is 1 by s, e to the power at is 1 upon s minus s, uh, uh, 1 upon s minus a. Then sine hyperbolic at is a upon s square minus a square. Cos hyperbolic at s upon s square minus a square. Then sine at a upon s square plus s square, s square plus a square. Then cos at is s upon s square plus a square. Then t to the power n factorial upon s to the power n plus 1. and then unit step function ut minus a is e to the power minus as by s. So this much you should remember. Okay, then only you can quickly solve. And this was the basic formula. So if you don't know anything, you should know the basic formula, that integral formula. To write the Laplace, this formula you should remember, because if you don't know the formula, you can derive it quickly, you can calculate using this, na? Okay, so now the inverse Laplace is written seeing the Laplace. So let me tell you what I mean. So suppose this is Fs and this is Ft. So if I say what is inverse of 1 by s, क्या होगा आंसर?
1.
1.
1, sir.
What is inverse Laplace of 1 upon s minus a?
A raised to it.
E to the power of
What is inverse Laplace of a s square minus a square? What is inverse Laplace of s upon s square minus a square?
1 hyperbolic.
What is inverse Laplace of a upon s square plus a square?
Sin 80. Sin 80.
What is inverse Laplace of s upon s square plus a square?
Cos 80.
What is inverse Laplace of gamma n plus 1 upon s to the power n plus 1?
E to the power of
And what is inverse Laplace of e to the power minus as by s?
function. Ut.
So these are inverse Laplace. So inverse का idea तभी आएगा जब Laplace पता है, correct? The idea of inverse will be only there when you know the Laplace, because seeing the question we can directly write the inverse Laplace of so many things. So I will give you an example. This you already know, the same chart I have made. Just to revise, I hope you now you all remember this much or not? Yes?
Yes, sir.
Yes, sir. Yes, sir.
Now suppose somebody asks you uh, what is inverse Laplace of s plus 2?
E to the power
E
minus
to the
two.
power
minus
2s.
Minus 280.
So you will write it like this: 1 upon s minus minus 2. So this is, what is a here?
Minus 2.
Minus 2. So it will be e to the power 80. So e to the power minus 2t. This is the inverse Laplace. Correct? So there are the properties that will be used in Laplace transformation. So we already know 8 Laplace, and we can make so many questions out of that. For example, I will give you an example. Suppose somebody asks me, what is the Laplace of t square? So what I will do? Gamma 2 plus 1.
S to the power 2 plus 1.
Gamma 2 plus 1 over s to the power 2 plus 1. So 2 by s cube. Bolo.
Yes, sir.
This is one question. Another question is, what is inverse Laplace of 2 by s cube?
E square.
So it is t square. So these two are very very important thing. अगर आप समझ जाओ तो इससे 50 क्वेश्चन बना सकते हो. So this was Laplace, this was inverse Laplace. and sometimes this 2 will not be given. Suppose somebody asks you 1 upon s cube, then what you will do? So you will write it like this: 1 by 2 inverse Laplace of 2 by s cube. Yes? And it will become 1 by 2 into t square. Correct? So this is the symbol of Laplace and this is the symbol of inverse Laplace. So these operate like in Fourier also. The symbols are like this. If this f is written, this is Fourier, and if this is written, this is inverse Fourier. Okay. So I think symbols we understand. If you have little knowledge about what is happening, the symbols will not make any problem to you. Okay. ठीक है ना?
Yes, sir.
So now there are some properties that are very important in Laplace. Like we had properties in Fourier. So there are properties here also associated to Laplace transformations. And the first property is shifting. Shifting theorem. What is this shifting theorem? That if we know that the Laplace of ft is fs, if we know that Laplace of ft is fs, Laplace of e to the power at ft is f to the power s minus a. इसका प्लीज अंडरस्टैंड दिस. एग्जाम्पल देता हूं आपको, बहुत सिंपल एग्जाम्पल दे रहा हूं. सपोज 1 का ट्रांसफॉर्मेशन क्या है?
1 over s.
So if e to the power 8 is multiplied to 1, then if this should become f of s minus a. That means it should become, देखो समझ आता है?
Yes.
आता है सर समझ.
Like another one, t square, Laplace of t square is
Cubed.
2 upon s cube.
2 by s cube. Laplace of e to the power 2t t square. So this 80 is multiplied. Let me give you minus 2t. Suppose this is multiplied. So what will be your new Laplace?
1 upon s plus 2.
2
S plus
upon
2 cube.
s
2 upon
minus a. So it will become s plus 2 whole cube.
Yes, sir.
Now see, this is not easy. If I ask inverse of this, it will be this. Are you getting my point? So you have to see कि पहले 2 by s cube देखो, बाद में देखो कि shifting हुई है. Correct? First of all, see 2 by s cube, then see that the shifting must have happened. Suppose somebody asks you, what is inverse of 2 upon s t cube? This. Inverse Laplace. So first of all, as a first step, you will write 2 by s cube is what? T square. And then make shifting. 2 by s plus 2 cube. Shifting has been done. So it will become t square e to the power minus 2t. I hope you are getting my point.
Yes, sir. Yes, sir.
So this is the way to look at Laplace and inverse Laplace. Both see simultaneously. So every question will become 2 questions. Let me solve another one. What is Laplace of e to the power at cos bt? This is the question. So we know we can do it by first shifting. So I will write first of all Laplace of cos bt. What it will become? S upon s square plus b square. Then using first shifting, I will write e to the power at cos bt. It will become s minus a upon s minus a square plus b square. Check this. देखो समझ आता है? Are you able to understand it?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Very
Got it, sir.
got it? Okay. So let me take another problem. Write the inverse Laplace of, so fs is given 3s minus 137 over s square plus 2s plus 401. And I want ft. So how to approach this? Please see this. Here it is s square plus 2s. So the first step will be to try to make it a perfect square. So we can't do much. We can only write this as s plus 1 whole square, because you know 2s is there, that will only come when it is s plus 1 square. You can't write anything else. ये बात समझ आती है? Are you able to understand this?
Yes,
Because
sir.
of this 2s, we always see this term. So fs will be 3s minus 137 over, this will be s plus 1 whole square. And what will remain? So it will become s square plus 2s plus 1. 1 has gone
100.
here.
Plus 20 square.
So plus 20 square. So we can write this as 3s over s plus 1 square plus 20 square minus. So now please see. This will be s square plus a square, na? So we have to write 137 into 20 by s plus 1 square plus 20 square and by 20. Please see this. You understand?
Yes, sir.
Now apply inverse Laplace ft. So this is s over s plus 1 square plus 20 square. So how to handle this? So the first step will be, we will have to write it as 3s plus 1, because I want s plus 1 here. So 3 is extra, so I will have to write minus also. Tell me if you agree with this. So this will become 3. I hope you are understanding in what direction I want to move. S plus 1 square into 20 square.
Yes, sir.
And minus, it will become how much? Minus
minus
137 था ना? And 3 140 हो जाएगा?
140 upon s plus 1 square plus 20 square.
140 by
Upon
20. So let me not do it right now. I will do it after this step, after just taking this 3 also into that care. 140 into 20 upon 20 s plus 1 square plus 20 square. Please see this. And this will be 7. Now everything is ready. अगर आप understand कर रहे हो कि मैंने क्यों s+1 यहाँ लाया, why I have, because there is shifting will be involved ना. So abhi right now it is fs. Right now it is fs. So now I am going to write ft. So please see, this is first of all s upon s square plus a square. What is that?
cos
Cos
s plus
3 times cos of, so s upon s square plus 20. So first of all it is cos of 20t. Now then there is a shifting of 1, so that
e to
means
the power
e to the
minus
power minus t.
t.
Now see, cos ka s upon s square plus 20 square, and then if it is shifting e to the power minus t, then shifting of minus 1 will happen. It will become s plus 1, it will become s plus 1. Got it? Minus 7. This time also see, a upon s square plus a square. So that is sine of 20t. But again there is a shifting. So it will be e to the power minus t. So this is the answer. Please see this. If you understand this much, then you can do any question.
Yes, sir.
So you have, ये पहले ही आता हुआ दिखता है. You have to anticipate it. You can see the answer coming before it actually comes. That s plus 1 is involved or the shifting is involved. You can see it. That's why I arranged everything to become s plus 1 so that I can apply the shifting formula. Anybody has any doubt, you can ask. So you can plot this also if you want. The ft can be plotted because ft is like this, na? E to the power minus t, 3 cos 20t and minus 7 sine 20t. So it can be plotted because, you know, this is sinusoidal function. Some sinusoidal function, and this is exponentially decaying. So at t is equal to 0, it will have some value. And after it, it will be oscillating and decaying because of this term. So you can just plot it. F of t and t. Okay. So let me stop here and we will take this. So you just see this, you will be able to gain the level at which the questions are asked in your exams. Okay, so basics today I have told you all the basics, so this much is will be enough to solve any question. We will now solve random questions here and there, learning the properties and questions. Okay, thank you.
Thank you, sir.
Thank you. So let us practice questions from Laplace transform. I gave you yesterday in previous class, I gave you the complete briefing of how the Laplace transformations will be done. So now quickly let us revise those things using some problems. So suppose I want to calculate the Laplace of a minus b t square. Okay, so how I will do this? I will write a square plus b square t square minus 2abt. Correct? This is the question, and I want to calculate Laplace of this, so I will write it like this: a square plus b square t square minus 2abt, and this side I will write the Laplace. So this is 1. So a square by s, correct? And then plus b square. What about t square?
2 by s cube.
So it will be 2 by s cube. And what about t? 2abt.
1 by s square.
1 by s square. So this is the Laplace. This is the Laplace of that. Next question. Suppose I want to write cos of pi t, Laplace of this cos of pi t. So Laplace of cos of pi t will be s upon s square plus pi square, using the formula directly. Then suppose I want Laplace of cos square omega t. So cos square omega t, I will write it as 1 plus cos 2 omega t by 2, and then I will write its Laplace 1 by 2s plus 1 by 2 cos 2 omega t will be s over s square plus 4 omega square, correct? Then suppose I want to write Laplace of e to the power minus t sine hyperbolic 4t. Suppose I want to write Laplace of this. So first of all I will write Laplace of sine hyperbolic 4t, that will be given by 4 upon s square minus 16. And then I will write Laplace of e to the power minus t sine hyperbolic 4t, and that will be given by 4 upon s plus 1 square minus 16, using shifting theorem, first shifting theorem. Is that okay?
Yes, sir.
So these are small questions to practice. So suppose I want to write it for Laplace of cos of omega t plus theta. I want to write Laplace of this. So it will be given by Laplace of cos omega t cos theta minus sine omega t sine theta, correct? Laplace of this. So that will be Laplace of cos omega t will be s by s square plus omega square cos theta minus sine omega t will be omega by s square plus omega square sine theta. So this will be the Laplace of this, correct? Similarly, in next question, suppose we have to find out Laplace of this. This is 1, this is 1, this is t, and this is ft. We have to find out Laplace of this. So how to do that? So the first step is to write the function itself. It is given by, what is the slope? Minus 1. So minus t, and what is the intercept? 1. Minus t plus 1. And it is between 0 and 1. So how to write the Laplace? Can you tell how to write?
Yes, sir.
The definition.
Minus t plus 1.
1 upon s minus.
No.
So definition.
Because that definition is from 0 to infinity. So we will write here as f of s is equal to integral 0 to infinity e to the power minus st ft dt. And that will be here 0 to 1 e to the power minus st, and ft is minus t plus 1 and dt. And from 1 to infinity it is 0. Correct? Understanding? So this integral, let us do it quickly. The integral, it is given by f of s is equal to first function integration of second minus derivative of this integral of this. This complete thing is 0 to 1. So when you put the limits 1 here, it will become 0, and when you put 0, it will become minus 1 by s. Lower limit, correct? And here plus 1 by s square, upper limit will become e to the power minus s, and lower limit will become 1. So whole thing will become 1 by s plus e to the power minus s by s square minus 1 by s square. Please see this. Check this. Is this okay? So when some function is given which is not in the range of 0 to infinity, then you have to use the basic definition. This you can write as a note, otherwise immediately your answer will be wrong. More questions for Laplace? So suppose you have a question like this, in which the function ft is given like this. This is some a point, this is b point, this is t, and this is k, and this is ft. We have to calculate Laplace of this. We can do it by basic method also. But if you see, this time the ft is equal to k times u of t minus a minus u of t minus b. I told you that the barrier function can be written as a unit step function, correct?
Yes, sir.
So what will be the value of fs? That will be equal to k times, इसका क्या बताया था? e to the power minus as by s minus e to the power minus bs by s. यही बताया था ना? What was the Laplace of ut minus a?
Yes, sir.
Yes, sir.
So this is a method, and you can apply this u thing to any function which is in a range and otherwise 0. You can do it with any of the functions which is present in some region and absent, because suppose this is 1 unit, so if there is a function in between, you can multiply with that. बात समझ रहे हो क्या कह रहा हूँ? Suppose in previous question it was like this, 1 1. So this can also be written in the form of unit step function, because this function ft will become you know this is present in this range, and the definition is minus t plus 1 suppose, and multiplied by ut minus 0 minus ut minus 1. So it will become something between the range, complete range. Now this definition can be used generally, okay? So this is how you can write any of the functions which is present between some range and absent otherwise. You can write them like this. So now let us also practice some inverse Laplace transformation, because ultimately that will be very important. We should know how to calculate the inverse Laplace of few functions, and I told you yesterday also, because we know few definitions, we can always calculate. We know so many definitions of, so let us write inverse Laplace. Okay, so suppose I have a function fs which is 0.2s plus 1.8 over s square plus 3.24, and I want to write the inverse Laplace of this, because this is fs, I want ft. So I can write this as 0.2s by s square plus 3.24 plus 1.8 by s square plus 3.24, correct? And this will become 0.2s over s square plus 1.8 square plus 1.8 over s square plus 1.8 square. So this will become 0.2 cos of 1.8t plus, what will be this?
Science.
Sine of
Sine of
1.8.
1.8. So this will be ft. This was fs. Sine of 1.8t. So this is how to do the inverse Laplace. Next is, suppose we have some fs. So this was fs. Fs is given by 1 over s plus a and s plus b. Suppose I want inverse Laplace of this. So I will, in a first step, I will write fs is equal to some a upon s plus a plus some b upon s plus b, which is known as partial fraction. And when you write this equal to 1 upon s plus a into s plus b, so what will happen? This will become as plus ab plus bs plus ba is equal to 1. So if you compare, it will become a plus bs plus ab plus ba is equal to 1. So it is actually 0s plus 1. So compare the coefficients of s, you will get a plus b is equal to 0, and compare this, you will get ab plus ba is equal to 1. So from here you will get a is equal to minus b, and if you write this, you will get a is equal to 1 minus ba upon b. So I mean we have to solve them. जैसे भी solve कर पाओ solve कर लो. So we can solve it like this also, by multiplying it by b and then subtracting. So this will become bb minus ba is equal to minus 1. So you take b common, it will become b minus a is equal to minus 1. So b will become 1 upon a minus b. So now we can write this partial fraction is important. We have to use it at many places. So how the fs will become now? It was a upon and b is 1 upon a minus b. So it will become 1 upon a minus b, 1 upon s plus b minus 1 upon s plus a. It will become like this. So if I write f of t, it will become 1 upon a minus b, and now you can see from here it will become
e to the power minus b
t
minus t.
and minus e to the power minus a t. So this is the answer. Okay. So such questions we will be able to do. Now two important properties are the Laplace transform of derivatives and integrals, like we did in the case of Fourier transformation also. I told you that Laplace is also a very important method to solve the differential equations with the initial conditions given. So let us learn that Laplace transform of derivatives and integrals. Of derivatives and integrals. Let us learn that, how to go about this. So if Laplace of ft is fs, suppose this is the symbol that I am using, then the question is, what is Laplace of nth derivative of t? What is Laplace of nth derivative of t? So this is s to the power n fs minus, please see what will happen. This s to the power n, power will continuously decrease, so minus s to the power n minus 1 f of 0, Laplace of f n t will be s to the power n fs minus s to the power n minus 1, and this will continue minus s of n minus 2 f dash 0, like that. Okay, so n minus 1, n minus 2, it will go on. And so suppose as an example I want to write Laplace of second derivative of t. Suppose this is the case, so it will become यहाँ पे s to the power n fs capital लिखो because Laplace is fs ना. So second derivative will become s square fs, where you know what is fs, it is Laplace of ft, and then minus s 2 minus 1 f0, and minus it will become f dash 0. No other term is required. And what is Laplace of ft? First derivative, it will become sfs minus f0. Please see this. So for example, I want Laplace of cos at derivative. Please see this. I want Laplace of cos at derivative, so it will become this first derivative, it will become s of fs. Fs means Laplace of cos at. What is that? S by s square plus a square minus f0. So what is value of f of 0? 1. So it will become s square minus s square minus a square by s square plus a square. So it will become minus a square by s square plus a square. Please see this. This was very simple question to just understand. अब suppose मुझे दूसरे तरीके से करना है. So Laplace of cos dash will be minus a sine of at. Correct? Cos derivative. So it will become minus a. What will be the Laplace of this? A by s square plus a square. And see, the answers are same. Understood this property or not?
Understood, sir.
So this example was just to explain you what is the property. So this I have done by normal, and this I have used the property. So this was about derivatives and about integrals. So derivative is clear. So Laplace of, now integral property. Suppose we know that the Laplace of ft is fs. This we already know. So now the question is, what is Laplace of integral 0 to t ft dt? And the answer is 1 over sfs. So जब भी 1 upon s आएगा, here you have to, for example, suppose you know here some, I write some s by s square plus pi square and into 1 by s. Suppose this is written and I want to know what is inverse Laplace. Please see this, very very important. 1 by s is multiplied. So if 1 by s is multiplied, how I will write? I will first of all write the inverse Laplace of this, which is ft. So I will write it like this: 0 to t. What will be ft? Cos of pi t and dt. So inverse Laplace of this will be this. Please see this. This is very very important. बहुत बार previous year इसी पे based आया है, 1 upon s पे based. That you know Laplace of this, but you don't know Laplace of 1 upon this. So just integrate that, you will get. ये notations अगर clear हैं आपको तो. Got it or not?
Got it, sir.
So suppose you have this question, suppose 1 over s minus a. You want inverse Laplace of this. So this side you will write integral 0 to t
E power 80.
e to the power at and dt. Suppose it is written 1 by s square s minus a. So you will write
e to the
0 to t into 0 to t e to the power at dt and dt. Got it or not? Whatever. So this will become a new question, na? Suppose you get after integration. Suppose you get here this side. Forget about this. Suppose it was like this: 1 over s 1 upon s minus a. So you got here some ht. This will be a function of t. Whatever integrations you do, you will get some ht. Correct? Or if you actually want to write, so you write it e to the power at by a 0 to t. What you will get? E to the power at minus 1. Huh? So you will get e to the power at minus 1 over a. Correct? Yes? Now suppose this side it is 1 over s square. So what I will do? I have 1 by s. This is already there. Now one more time 1 by s has come now. Like this. This much we have already completed. Iska inverse Laplace is written here. Now for this what will happen? Integral 0 to t e to the power at minus 1 by a and dt. Again. समझ आया या नहीं?
Yes, sir.
What about others?
Yes, sir.
Yes, sir.
So if it is in the denominator it is s square, that means you have to apply the integral property twice. So I hope such questions you are able to understand. And I want to do one. Yes, this one. Suppose I will use this property in many cases. Okay. Suppose you have a question 3s plus 4 3s plus 4 upon s to the power 4 plus k square s square, something like this, and you want inverse Laplace of this. That is the question. Inverse Laplace of this we have to calculate. Okay, so now this will become inverse Laplace. So I can write it this side, 3s plus 4 over s square plus k square. Correct? Yes or no? And it will become 1 over s square 3s over s square plus k square plus 4 over s square plus k square. Correct? And you will have to multiply it by k and divide it by k also. So first of all, see what about this. So this side you will have to write first of all. अभी 1 upon s square को ऑपरेट नहीं किया है. Just this, agar if I want to write the inverse, what I will get? 3 times cos of kt
KT
plus 4 times sin of kt. सबको समझ आ रहा है? And then 0 to t dt, and whatever we get again 0 to t dt. Correct?
तो 4 by q होगा ना.
Sir, 4
K
by
भी आएगा
K.
डिवाइड
4 by
K.
4 by k. Please see this. Understood or not?
Yes,
So
sir.
1 time 1 by s will come and then again 1 by s will come.
Okay, sir.
So whatever you get here, you have to integrate again it to 0 to t. So you will calculate here and that will be the inverse Laplace of this question. You can integrate or not this question?
Yes, sir.
Cos का sin का simple integration है. You can do it. And you know, so please remember 1 upon s thing. This इस type के question बहुत बार exam में पूछे गए. 1 upon s square because you have to integrate it twice. And after integration, ये सब लोग homework में कर लेना. You will get 3 by k square and 1 minus cos of kt and plus 4 by k square and t minus 1 by k of sine of kt. This you will get. Do it as a home exercise. Simple question, not very tough one. And do this also as a home exercise. Inverse Laplace of 1 upon s square s plus a. You can do it. कर लोगे ना? Yes or no?
Yes, sir.
Yes, sir.
So now let us see how this Laplace is applied to calculate the initial value problem. How we use Laplace to solve initial value problem. So सब बहुत ध्यान से इसको समझना. So the dy by dt minus plus ay is equal to e to the power minus bt is given and y0 is given equal to 0. This is the question and we have to solve this using Laplace transformation. Correct? समझ आ रहा है? This is the differential equation. We have to solve it using Laplace transformation. So what I will do, first step, take Laplace on the both sides. So what will be the Laplace and let Laplace of y को कुछ मान लेते हैं. Let us take it capital Y. Yes. Okay? Just to make it easy. Or you can also take y tilde, whatever you like symbol. So यहाँ पे क्या बनेगा? Derivative वाला फार्मूला लगाओ. S ys minus y0 plus ays is equal to, what about this? 1 upon s plus b. Tell me, आ रहा है समझ?
Yes, sir.
Yes, sir.
This is given to be 0. So ys, which is Laplace of y, if I take common, it will become s minus s plus a will become 1 upon s plus b and ys will become 1 upon s plus a into s plus b. अभी अभी इसका लैप्लास किया है तुमने, इनवर्स लैप्लास. सो व्हाट विल बी द yt और inverse Laplace of this? Because Laplace of y is capital Y ना. So what is inverse Laplace of this? So tell me, अभी अभी तो लिखा है 1 upon a minus b
e to power minus b
minus.
minus 8.
This is the solution of the differential equation. So please see the steps. This is how differential equations are used. Laplace is very very powerful tool to solve the differential equations. देखो समझ आ रहा है? ये वाला स्टेप समझ आया सबको?
No, sir.
Yes, sir.
किसको नहीं आया समझ?
मुझे नहीं आया समझ.
क्या किया होगा मैंने, बताओ जरा, सोचो.
सर y का डेरिवेटिव विद रिस्पेक्ट टू टाइम है, डिफरेंशियल इक्वेशन उस हिसाब से आपने पुट तो क्या है, पर वो मुझे समझ
नहीं,
में
मैंने
नहीं
क्या
आ रहा
पुट
है.
किया है इस स्टेप में, मैंने क्या किया है ये तो बता दो. कैसे किया है वो तो मैं बता दूंगा. व्हाट आई हैव डन.
Inverse.
टेकिंग लैप्लास. मैंने लैप्लास ले लिया है. तो अगर y डैश t का लैप्लास लिखूंगा, जबकि yt का लैप्लास ys है. लैप्लास ऑफ yt इज व्हाट इन आवर सिंबल? ys. यही बोला है ना मैंने? लैप्लास ऑफ yt इज ys. So
yes.
what will be Laplace of y dash t? That is the question. So it will be s ys minus y of 0. ये जरा फॉर्मूला देखो ना, डेरिवेटिव्स ऑफ लैप्लास.
So using differential.
लैप्लास ऑफ डेरिवेटिव्स जो मैंने सिखाया है वो देखो जरा, फिर देखो समझ पा रहे हो.
यस सर, एस एफ ऑफ एस माइनस एफ ऑफ जीरो था फंक्शन में. यस सर, समझ में आया अभी.
अब उतना ब्रेन होना चाहिए कि f है तो y है, वो सब वेरिएबल्स तो पता होने चाहिए ना. वो आपको थोड़ा भी अपने को भी खुद को भी दिमाग लगाना है.
सर वो लाप्लास का है पता नहीं चल रहा था, विथ रेस्पेक्ट टू
नहीं नहीं
टाइम
नहीं,
डेरिवेटिव वही दिमाग में
आई एम
रह
नॉट
गया था.
टॉकिंग अबाउट यू ओनली, आई एम टॉकिंग अबाउट इन जनरल कि द वेरिएबल्स विल चेंज. कहीं f लिखा है, कहीं y लिखा है, तो आपको तो अपना समझ के चलना है ना. सो द फर्स्ट स्टेप इज टेकिंग द लैप्लास. और वही मैंने लैप्लास के एडवांटेजेस में लिखवाया था फर्स्ट डे. आई टोल्ड यू दैट द इनिशियल कंडीशंस आर यूज्ड डायरेक्टली. अलग से पुट करने की जरूरत कहीं पड़ी? नो, डायरेक्टली द इनिशियल कंडीशंस इज यूज्ड. एनीबॉडी एल्स जिनको समझ में आया हो? In exam they have asked, if this is the differential equation, what is Laplace ys? They have asked this question. Because if I ask you this, you may solve it using some other method also, na? This is also linear equation, na? समझ रहे हो कि नहीं बात को?
Yes, sir. Yes, sir.
You can make it variable separable or so they have not asked this to check whether you know Laplace. They have asked this. Now let me take another question of this type to make you understand. Suppose there is a circuit like this, or this is capacitor, this is inductor, and this is the source, and the source voltage is the delta function. Okay, the source voltage is the delta function, and we have to calculate the voltage. So we know, and the value of R is given 20 ohm, the value of L is given 1 Henry, and the value of C is given 10 to the power minus 4 farad. So we know the equation will become Q double dash plus 20Q dash, second order differential equation, plus 1000 10,000 Q is equal to delta function. So this you already know. यहाँ तक आपका इलेक्ट्रॉनिक्स का काम है, ये आप समझते हो या नहीं समझते हो? This is IR, this is IXC, and this this is IXC, and this is IXL, correct? These are the voltages about this.
LDI by dt.
So because it is time varying, here it will become, the voltage will become LDI by dt, LDI by dt. Here it will become V
Q by C.
Q by C, and here IR. So to make everything in terms of Q, what will happen? It will become d2Q by dt2. Yes or no? Current is also derivative of charge, and here it will become Q, and here will become dq by dt. And then they have summed up and then divided by L, and then the values are put and you will get this, correct? Everybody understood this? Now I want to know what is Q, and also I want to know what is current. So the first step is, so let us understand that Q का Laplace Q tilde से लिख देता हूँ simplicity के लिए, okay? You are okay with it? This is QT, and this is QS. This is Laplace of this. Now take the Laplace here. डबल डेरिवेटिव है, क्या होगा Laplace याद है? S स्क्वायर FS, बोलो भाई, माइनस, देख के बताओ, सेकंड ऑर्डर का भी लिखवाया है मैंने, S
Minus
S
S
F0
window. F of 0.
F of 0
minus F dash
minus
Q dash 0.
Q dash 0
Q dash 0 is equal to, फिर प्लस 10,000
20 Q dash.
Q tilde. इसका तो डायरेक्ट हो जाएगा ना, नहीं पहले इसका, सॉरी
20 Q dash.
20. What about this Q dash? S into Q tilde S minus Q0 SFS minus F0 and plus
Q dash आएगा ना सर?
what?
I correct.
तो
पर-
Q dash tilde ऐसे बोल रहे
तो Q dash ये, so plus 10,000 QS is equal to delta function. What will be Laplace of that? 1. If you take Laplace of this, it will become 0 to infinity, and delta function e to the power minus st and dt. and it will become equal to 1. Correct? So the next step is to write. So suppose initial charge and initial current both were 0. This is given. Otherwise, you will have to use that, whatever is given. So suppose they both were 0, then now this is the final one. If you have any doubt how I have written, you can ask. So what is Q tilde S equal to? You calculate it from this equation. It will become 1 upon S square plus 20S plus 10,000. And this will become 1 upon, make it perfect square, S plus 10 square plus 9900. And now you know what I am doing. So this will become 1 upon S plus 10 square plus 99.5 square. So this will become 99.5 divide and 99.5 multiply. So it will become 1 upon 99.5 into e to the power minus 10t sine of 99.5t. This is the solution. Any step you want to ask, you can ask. So after this was Q tilde. That means Laplace. But here what I have written, QT. Inverse Laplace ले लिया इस step में. So this may itself be a question, that what is QS? What is Laplace in this case? And then the solution, because right side is delta function though, so you can't solve it by normal method. Please ask if there is any doubt at any step.
No doubts.
So ये कैसे Laplace लिख रहे हैं, फिर कैसे derivatives का सब लोग अच्छे से सीख लो. जैसे स्क्वायर का ही सीख लो बस, तो सब बातें समझ आ जाएंगी. एस स्क्वायर एस f0 minus f dash 0. So let me stop here. Thank you so much.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.